All right, so in part one of this of 6.4's video, we talked about the geometric sequences. In part two's video, we're going to talk about word problems using geometric sequences. So let's look at number 4. The number of subscribers to a blog doubles each week. How can the trend in subscribers be modeled? So since we know it doubles each week, that means we're multiplying by 2 each week. So it is going to be an exponential function because we're multiplying by 2 each time. So that means we can use our geometric sequence because geometric sequences are exponential functions. So we are going to want to write our explicit formula. Remember that formula is an equals a1 times r to the n minus 1 power. So we're going to need a few things to write this equation. We need a1 and we need r. We know it doubles each week, so that means r is going to be 2. We multiply by 2 each time. And if we look in this picture, it tells us in our first week we had 5 subscribers. So that means a1 is 5. So we have r is 2 and a1 is 5. So we can write our geometric sequence. an equals a1, which is 5, times r, which is 2, to the n minus 1 power. Part B asks, how many subscribers will there be in week 9 if the initial number of subscribers is 10? So now instead of having 5 subscribers to begin with, we're going to have 10. So that means A1 is going to equal 10. It's still doubling each week. We're just starting with 10 subscribers instead of 5. So our formula is going to be very similar. It's going to be AN equals, instead of 5, we're going to have 10. That's our initial amount, our y-intercept, times 2 to the n minus 1 power. That's just our equation though. That's not what it asks. It asks how many subscribers will there be in week 9, if the initial number of subscribers is 10. So we want to plug in 9 for n. We want to find the 9th term. So A9 is equal to 10 times 2 to the 9 minus 1 power. So 10 times 2, 10 times 2 to the 8th power, which, if you plug that into your calculator, should give you 2,560. So after 9 weeks, there will be 2,560 subscribers. Let's look at number 5. Number 5 is a little different. Not much, but just a little. So it says the number of people attending the annual Town International Food Festival has decreased 20% each year since the first year. So it's decreased 20% each year since the first year. How can the attendance for the first 5 years be modeled? So we need to write a equation. Since we need the first 5 years, we don't necessarily want to find just the 5th year. We want to find all 5 years. So we want to find the first year, 2nd year, 3rd year, 4th year, 5th year. So that means we're going to want to use our recursive formula. So remember, with the recursive formula, you have to tell me A1 equals, and then the formula is AN equals R times an minus 1, and that n minus 1 is a subscript, so that's like the previous term. Be careful with this one though. So our rate, it's decreasing 20% each year. So that means our rate is going to be 80%. But just like with exponential decay, you can do 1 minus the rate, so 1 minus 20%, which would give you your 80%. And we cannot leave it as a percent, So if we have 80%, we have to write that as a decimal. So my decimal is behind the 0. I have to move it 2 places to the left. So I'm going to get 0.8. So my rate is going to be 0.8, and I need my A1. A1 is our initial amount, our starting amount, and if we look at this flyer, it tells us that 1,250 people attended last year. That's A1. So 1,250 is A1. So we can write our recursive formula. So it's going to be A1 equals 1,250. Then AN equals our rate, which is 0.8, times AN minus 1. So that's our formula we're going to use to find the first 5 years. So we know our first year. We know A1. I'm going to write it over here. So A1 we know is 1,250. So now we need to find A2. So to find A2, we can plug it in. So we have A2 is equal to 0.8 times A to the 2 minus 1. So A2 minus 1 is just A1. So we have 0.8 times A1. And we know that A1 is our 12,500. No, I said that wrong. 1,250, sorry. So we can multiply 0.8 times 1,250, and that gives us 1,000. So that means A2 is 1,000. Now we can use A2 to help us find A3. So for A3 is equal to 0.8 times A3 minus 1. So 0.8 times A2, which we found A2 was 1,000, so 0.8 times 1,000. Oops, forgot a 0. Which gives us 800. So A3 is 800, which we can now use to find A4. So we're going to have A4 equals 0.8 times A4 minus 1, which is A3. And we know A3 is 800, so 0.8 times 800, which gives us 640. So A4 is 640. And last we have to find A5. So I'm out of room, so I'm going to put it in the middle right here. So A5 equals 0.8 times our previous term, A4. So A5 minus 1, which is A4. So 0.8 times 640, which gives us 512. So A5 is 512. So the first 5 years can be modeled by 1,250, 1,800, 640, and 512. Part B says, if the trend continues, what will the attendance be in 10 years? Do we really want to keep going? So in order to find, if we keep using our recursive formula, in order to find A10, we're going to have to find A9. In order to find that, we have to find A8. To find that, we have to find A7. So that's going to be quite a bit of work. Or we can just use our explicit formula. So we're going to have to create our explicit formula. So remember, the explicit formula is AN equals A1 times R to the n minus 1 power. So we have AN equals, we know A1. Remember, it told us in our flyer that 1,250 people attended last year. That's A1. So 1,250 times our rate. We know our rate is 8% or 80%, which is 0.8 to the n minus 1 power. So now we can use that formula to find the attendance in 10 years. So we can plug in 10 for n. So A10 finding our 10th term, is equal to 1,250 times 0.8 to the 10 minus 1 power, which is 1,250 times 0.8 to the ninth power. Y'all be careful when you're plugging this in your calculator. Make sure you're doing 0.8 to the ninth power. So do not multiply 1,250 times 0.8, hit enter, and then do to the ninth power. That's not right. I want you to do all in your calculator, all in the same line. You can do 1,250 times 0.8 to the ninth power. Or if you want to do it on two lines, you're going to need to do 0.8 to the ninth power first and then multiply by 1,250. Which that should give you 168. Which means in 10 years, only 168 people will come to the annual Town International Food Festival, which is kind of sad. Wish more people would attend. Let's look at our last one that we need to, number 6. So number 6 says the formula AN equals 1.5 times A to the n minus 1 with an initial value of 40 describes the sequence. Use the explicit formula to determine the 5th term of the sequence. So we're given the recursive formula. We're given that A1, our initial value, is 40. And then our formula is AN equals 1.5 times AN minus 1. That's the recursive formula. We need to turn this into our explicit formula. So we need to find some stuff from our recursive formula that we need to use in our explicit formula. So remember, the recursive formula, this is our rate, and this is our previous term. So we're also told A1. So we know that A1 is 40. We know our rate is 1.5. Or our common ratio is 1.5. We're going to need that in our explicit formula. So our explicit formula is AN equals A1 times R to the n minus 1 power. So we can fill in what we know. AN equals A1, we're told, is 40, times our ratio, common ratio, is 1.5 to the n minus 1 power. So that is our explicit formula. We're going to need to use it to determine the 5th term of the sequence. So I'm going to plug in 5 for n. So A5 is equal to 40 times 1.5 to the 5 minus 1 power. So 40 times 1.5 to the 4th power. Once again, all of that goes on the same line in your calculator. Or if you're going to do it piece by piece, do the 1.5 to the 4th power first, then multiply that number by 40. And when you do that, you should get that your answer is 202.5. So the 5th term is 202.5. I hope this was helpful. If you have any questions, make sure you ask us. Either send us an email on Canvas, or you can also ask on the Facebook